So as a meteorologist, when I have to make a weather forecast, there's a couple things that I specifically look at. I look at the current surface map and radar to figure out where are the storms, where's the rain. I also figure out where high and low pressure is and where the fronts are. I also look at upper air maps, as the upper air maps are going to tell me what direction the fronts and the air masses and the storms are moving. It also shows me areas where there's warmth aloft and cold air aloft. And I look at computer data. Lots and lots of computer data, which is giving me information as to what it thinks the weather forecast is going to be like. If all the computers say the same thing, well, if I was smart, then I'm going to say the same thing as the computers. But frequently, they're off either by a little bit or sometimes they're off by a lot, and then it's up to me to decide which way to go. You are going to have an opportunity to do this yourself on our next lab, and it's going to be part of our final module, which is your final exam. I call it the final week. So that's coming soon. So let's go ahead and look at a specific example. Upper air maps can show storm tracks and upcoming cold and warm air, like I've said. There's two different types of flow patterns across the United States. This one that you're looking at here is called zonal flow. Notice how the lines are basically going from California straight across the country to the East Coast, left to right. You see the wind barbs are lined up perfectly with those lines. Weather moves very quickly in this kind of scenario, and weather changes can occur daily, if not every other day. The opposite of that is meridional flow. And if you take a look at the lines here, the barbs are following the lines, but they come in off California, then they go straight up into Canada, and then they come back down from Canada. It makes the Greek letter omega. And typically in weather, we call this an omega block. When you have an omega block, weather systems just don't seem to move. So we can be in the same weather pattern for days and days at a time. So let's look at a specific weather example that occurred in December 28th, 2016. That was a day where we had zonal flow. Our weather systems were moving quickly. That's the actual upper air map that we had. This is a look at the radar. And notice on December 28th, there's no rain in Pennsylvania, but if you look off to our west, just outside Ohio and Indiana and Illinois, there's a thin stripe of rain showers there, some of them a little heavier than others. So that rain is heading from west to east. That's headed our way. So taking a quick look at that map, I could say tomorrow I'm expecting some rain. But I back that up by looking at the surface map observations. This is that surface map, and notice out there just west of Chicago there is a cold front there. That cold front is what's producing those rain showers. That cold front should be moving towards us. I can get an idea of how fast it's moving, and maybe in the next day, day and a half, 2 days, the cold front will move through, we'll get showers and then some cooler temperatures behind it. Now let's take a look at a computer model forecast. This is just one computer model, and it's going to show us what it thinks will happen in the future. So this is 12 hours later, very early Thursday morning. Notice that the front has moved through Chicago and is now in Ohio. Notice there's actually a storm system that's developed along the front, just north of Atlanta. All of that rain is headed in our general direction. So what I want to do is I want to superimpose the current conditions with this map here, the forecasted conditions. There you go. Do you see how the weather systems have moved? There are my two low pressure systems moving from west to east in the zonal flow. There's my front and my high pressure systems behind it moving from west to east. All of this is moving in the same general direction. Notice the stationary front that was below Atlanta, it started moving towards Atlanta in the Carolinas, so that stationary front turned into a warm front, and it's also generally moving west to east. If I now lay the upper air map on top of it, you can see, though it's a complicated map, that everything is moving with the zonal flow and along those height lines. So let's go ahead 12 more hours. So this is now Thursday afternoon. Notice by Thursday afternoon the computer thinks the cold front will have moved through just about. The storm system, that low pressure area, has moved through just about, and I know at this time that Pennsylvania's winds will be coming out of the north because they're going cyclonic around that low pressure, which is now over New Jersey. A little farther out in time, Thursday evening, everything is now moved offshore. And then this is the next day, Friday morning. This is the last map of our short-range computer model. If I want to look anywhere past Friday morning in time, I need to pull out and look at a little bit of a bigger picture and use a different computer model to look at that medium range forecast. So this is now Saturday morning. According to this weather map, on Saturday morning, there's a high pressure system off to the south of Pennsylvania, all the way down off the coast of South Carolina. I know the winds will go clockwise around that high, basically around the isobars. So we're going to have a south or a southwest wind. That's going to bring up warmer temperatures. And you can see there's a warm front in Ohio headed in our direction. Now, if I'm looking for snow in December, if I'm looking for a big snowstorm, then I'm looking for a low pressure system to track basically on one of these lines. We want that storm system to pass 150 miles to our south or 150 miles to our east. We'll explain why in a later lesson. If the storm travels on those lines and we're in cold air, we can get a lot of snow. It doesn't seem like there's a storm system that's going to follow those lines, though there's one trying to form in Texas that might get close. The other thing I look for is high pressure north of Maine. High pressure will form a block, and if the winds blow clockwise around that high, then a cold wind will come down out of Canada, and that will supply some of that cold air to make some snow. The wind would be coming out of the northeast in that case, and we would have a nor'easter. Nor'easters, winds from the northeast, usually a heavy snowstorm on the east coast. So this is now the weather forecast for Sunday. You can see storm systems haven't come close to us. They've moved well off to the north. I'm going to go back. This was Saturday. Notice the storm is in Wisconsin, and now it's up north of Vermont. This is Monday and Tuesday. So we're now 6 days into the future on our weather forecast. And on Tuesday, we have another storm system approaching with another shot of warm air coming. But the main storm system's going off to our north and west, so we're looking at rain here at the end of December. There's nothing on here indicating we're going to get a storm following those lines, even though if you look up north of Maine, we do have high pressure in place. The storm system in question, the computer thinks, will move this direction through Iowa and Wisconsin to the north of Michigan. And then it's going to track off to the north and east through Quebec. We'll be on the south side of it, which is the warm side of it, or the rainy side of it. Here we are on Wednesday, a full week after the day we are forecasting on, and that storm is all the way off to our north. If we want to go further out, we need yet another computer model. And you can see here that it doesn't show you storms or cold weather. It's just giving you a general trend. That in Lancaster, it looks like we'll be a little bit above normal on our precipitation 8 to 14 days out. And to look at the temperature, it looks like our temperatures are going to be a little cooler than normal. Notice it's not giving you anything specific. It's not saying 30 degrees. It's not saying it's going to snow. It's just saying the odds are elevated that it's going to be colder, and elevated there might be some precipitation. This is different from the 90-day forecast we saw from AccuWeather. On Wednesday, December 28th, if I go to the Weather Channel, they're going to show me the current temperatures, and there you can clearly see where all the cold air is. The purple color. It's off to the north in Canada, north of Maine. Pennsylvania is in a light blue color. It's in the mid to upper 20s. Now let's look at another weather situation. January 22nd to 23rd of 2016. We had a massive snowstorm where we got 24 to 30 inches of snow in Lancaster County. Some places saw more snow from this storm than any other in history. Here's the observed snowfall on those dates, and anything in the really dark red is close to 3 feet of snow. Notice the path that that snow takes. It starts in Kentucky, and then it really gets heavy in West Virginia, and it tracks all the way to Long Island. That snow fell to the north and west of the main storm system, and it falls about 150 or so miles away from where that main storm system tracked. This is what happened on the surface map for that storm. Notice the low pressures down there in Mississippi. As it approaches, it's now centered in Georgia. We have some snow and rain moving out in front of it. And now a little bit later, there it is off the coast of North Carolina. At this point, it's going to track right up that magical line. There it is off the coast of New Jersey. And it's right on the line that we need to forecast for a major storm. Now I'm simplifying it a little bit, but that's generally what we need to do. If the computer says it's going to follow that line, then I have to make a final determination. Do I think the computer's right? Because if it's only off by 30 miles or 100 miles, different areas are getting different amounts of snow. Up in Canada, the cold air was also in place, as the high pressure is just hiding off the top portion of the screen. So the overall track that this storm took was it went from Mississippi through to Carolina, it hit the Gulf Stream, it exploded, we call that bombing out in weather, and then it moved up the coast, and those isobars that are close together indicate real windy conditions as the pressure changes quickly over a small distance. We get a lot of snow, and then the wind blowing it around made for quite a storm. So this is what 3 feet of snow looks like on the ground. It's something that can be quite dangerous for people who aren't prepared for it. So I hope in this module you learned a little bit about climate and climate forecasting, as well as how a weather forecast is prepared. You will have an opportunity to do this in an activity coming up and at the end of our class. Our next video is going to be a quick tour of a local TV station, and you'll get to meet a local weather celebrity. And then in our next module, we're going to look at microscale forecasting, different types of weather events that happen in Lancaster, and how we can stay safe in them.